Jürgen, what will you be talking about today?
Good afternoon, everyone. My name is not Jürgen.
Okay.
Jürgen, unfortunately, is ill, so I have to stand in for him. My name is Carsten
okay.
Traupe.
I'm sorry.
No worries. I'm with IDS Imaging Development System here. Here's the name correct, but you're right, in the program it's still on.
Yeah.
Thanks for the good introduction into the Gigabit Ethernet standard, Maximilian. It was a really good startup, so to say, to build my presentation upon. As said, I'm Carsten Traupe from IDS Imaging Development Systems, and first some words to IDS. We are a family-owned business here from Germany, from close to Stuttgart in the city of Heilbronn, and we are one of the pioneers in computer and machine vision. This year celebrating our 25th anniversary, and we are fully family-owned and dedicated to innovation. But yet, being a German family-owned company, we have global reach and have sales subsidiaries all over the world, in Asia, America, Europe, Middle East. But development and production is all done here in Germany. Our products can be divided roughly in these three areas. The first thing is where we built the company upon is the UI, product range, 2D industrial cameras, where I'm going to speak about today. We also have our more recent development, the IDS Next vision system. It's an AI-based smart camera system, a complete system which also allows you to train networks and execute them on camera. And also the Ensensor range, a really versatile range of 3D cameras, enabling all kind of robotic guidance and bin picking applications with 3D technology. So I'm going to speak about the benefits of the 10 GigE standard today. And as a teaser, what drives us to these fast speed grades? And when you look really back to the history of imaging, this is where it started. You know, VGA and the amount of megapixels per second you needed to transmit to achieve certain frame rates. And this journey hasn't stopped. It's continuing further. So you ask yourself, what interface to choose? What am I trying to do with my camera, with my vision solution? And I'd like to highlight here a couple of considerations. And they're not meant to be considerations from the standpoint of a camera manufacturer. They are meant to be standpoints from an end customer, from an operator or a user of the system, of the complete system. So first of all, what we always hear about is the bandwidth of the interface, measured today in gigabits per second. But that's only one part of the equation. Of course, it needs to fit what you want to achieve, but you also need to consider cable length. Not always is the PC or the unit which evaluates the images very close to the camera. It can be just centimeters, it can be dozens of meters. And you need to take this into considerations. How reliable is the transmission? I think I can't do such a good job like Maximilian did here, but definitely these interfaces, they carry characteristics which also affect the susceptibility to disturbance from the outside. Power supply. Does the cable support power supply, allowing you a one cable solution in a sense that you do not have to provide separate power to the camera, but do this through the cable your images are transmitted through. Cost. Together with the camera, your interface is an important choice which determines the cost of your overall solution. I'm going to speak about this today too. Availability, and here I mean not is somebody able to ship, but does your chosen technology tap into an ecosystem which is specific to machine vision, or is there a larger ecosystem where you can get components from, maybe also achieving lower prices? And in the end, is there handling? How is the handling, installation, maintenance of these cables? I'm going to do this high level. But let me first look at what we are actually having on the plate here in terms of industry standards. So by now, there's, as already said, the Gigabit Ethernet vision standard on the top left. We have the Co-Express standard, what Mark talked about. We have the USB vision standard, and we have Camera Link. These three standards, so to say, form the pillars of any vision system needs to transmit its data through. And you would wonder, okay, this guy is speaking about 10 gig E interface. There's gig E vision. What is 10 gig E? And this is one of the benefits when you speak about 10 gig E interface. It builds on all the technologies we are already having for the 1 gig E standard. It's just faster. It's really that simple. In the end, it gives you 10 times the speed of 1 gig E, okay? Without having to adopt new protocols, understanding other protocol standards and so on. So let me try a high-level comparison. First of all, let's look at the bandwidth. So I always, here in this comparison with plus, I mean better, even if sometimes plus would, in a sense of a certain value, would mean worse. So when you look at the bandwidth an interface provides, when you look at CoExpress now on one lane on 12 gigabits per second, and Mark told you you can go with many lanes far beyond, for me this is in the same ballpark like 10 gigabits per second on the 10 gig E interface. Camera links 7 gigabits per second, slightly below. USB on 5. 1 gig E is really getting outdated when you look at these speeds currently on the market. When you look at cable length, the picture is again a little bit diverse. So here long cable lengths are very important when you're in a manufacturing environment where your camera is close to the machine, exposed to dirt, exposed to vibrations, and your PC is far away on the side on your shop floor. And then you really appreciate the long cable length of a gigabit Ethernet standards. And this is both true for 1 gig E and for 10 gig E cameras. Okay, the others, CoExpress comes close. You heard about the fiber advantages when you want to have really long cables. But here, these both interface standards, 1 and 10 gig E, really have advantages. When you come to reliability, you clearly see on this comparison the standards who have been made in terms of stability for kind of transmitting high-speed data all the time. USB definitely has a disadvantage. It depends on the power of the PC to pull the data over, while all the other standards, they show really advantages because the camera can send the packages through and they are then received and processed further. Power supply, very important. If you can have a power supply in your cable, then you save the cabling for the power. And this means you have a one cable solution, very much preferred, less handling, less cost. All these standards where I put a plus on, it's the PoE standards, they provide power over Ethernet in one cable. And USB has the power delivery standard, but it's not really broadly adapted in the machine vision world for cameras. It's a possibility, but it's not so common yet. When I look at cost, here really the power of tapping into a larger ecosystem, and I just bring in my next comparison, really plays to the advantage. These technologies, the network interface cards and also the cables, the whole technology, transmission technology, taps into a much larger ecosystem of the IT world, meaning you have much more vendors, more cost pressure on both sides, the network card and also on the cable range. And here you can really gain advantage in terms of cost and availability. We never heard about any shortage of or let's say a lack of diversity in gigabit Ethernet cables. While for the machine vision specific standards, you have to take what the companies who deal in this area provide. And then last, handling. I believe the known technologies of and the versatility of these cables you have with gigabit Ethernet standards really play to the advantage. I know CoExpress is also really handling friendly. Camera link comes from the industry. USB sometimes is a little bit cumbersome because it was not made for such robust environments. And then my conclusion, while I'm standing here, if you sum this all up in average, we believe the 10 gig E for modern machine vision camera is really the best standard, combining all these aspects. Yeah. Now, okay, there are more than 1 gigabit Ethernet speed, and I just name here 1 or 5 or 10 gig Ethernet. And you wonder, okay, what shall I look for? What is the best solution? And it's really hard to say because when you look at data here, it scales. It's the same interface standard. It scales really up with the bandwidth of the interface. Of course, you need the right cables, you need the right interface cards. But basically, you see 10 gig E is 10 times faster than 5 gig E, and then 10 gig E is 10 times faster than 1 gig E, and 5 gig E is 5 times faster than 1 gig E. So, what shall I look for? And in my view, when you look at these two speed grades, I put here a check mark on 1 and 10 gig E. The combination when you're looking for cameras, they really offer you the best combination in a sense that 1 gig E cameras are very reliable, as said before, but they're also cost effective. Yeah? They use very wide known and used components, while 10 gig E gives you the full power of the interface. Now, okay, what scales most? And here, let me conclude my talk here really, why we brought this interface to the market. These cameras need more power, they get larger. And by getting larger, you get larger sensors in. And that's the real, so to say, it concludes the argumentation. You need a larger camera, but the camera offers you also the larger sensors to get higher resolutions through the faster interface. So it's kind of going around in circles, and this is why we believe it's the best interface. And I invite everyone to look at our new Warp 10 camera on our booth from IDS, where we have a TFL mount on the camera, doing exactly what I said, bringing the speed of this interface, this reliable industry interface, together with large sensors with larger lenses. Thank you very much.
Thank you, Carsten. Do you have questions for Carsten? Anyone from the audience has questions? Oh, by the way, the panelists can also ask questions. So if you have questions, please feel free to shoot your questions at Carsten. I hope he will not mind.
No, I don't.
So if there are no questions from the audience, then I would have some questions.
Go ahead.
You started something provocative in your presentation. So you were comparing standards, right?
Yes.
And then you said, I conclude that 10 gig E is the one. So I would go back to my panelists now.
They will, of course, disagree. And I'm not saying these are bad standards. And you didn't see me give a lot of detailed figures and so on. And each of these standards has its use, has its applications. But when you look for long cables, you don't go for USB. Yeah? When you look for low-cost cabling, you most likely won't go for Co-Express. I'm not sure whether Mark would agree, but the comparisons we do, that for a certain cable length, and you have to, so the message I'm going to give you is you have to carefully balance what your application requires, and then take the right choice. But the argument I'm making is more from a statistical standpoint. When you look across all the applications, most likely you will be more successful with 10 gig E. Well, if you have specific needs, all the other standards are good standards. They're reliable in the sense.
So is IDS using the other standards as well in other products?
We use 1 gig E, USB, and 10 gig E, but we do not use Camera Link and Co-Express.
Okay, okay. Could you give us some examples? For example, you said it might differ from case to case, that you would use Co-Express or you would use... Could you give us some examples, real-life example? I would go back to the same question that I asked Maximilian. It was a different kind of question, but again, targeted or coming from a real-world perspective.
Yeah, I mean, first of all, when you need a lot of pixels, a lot of information from the camera, 20, 30, 40, 50 and beyond megapixels on your sensor, you need really a broadband interface to get these out in speed. And when you're looking at high-speed production, for example, one example I can give is glass inspection, where you have huge panels of glass you make for monitors and TV screens. Time is of the essence, and you want to shoot as much pixels as possible with one shot. You do several shots. These are large 5 by 7 meters glass panels. And the faster you can do all these shots and transmit the data out to the host, the faster you can go to the next panels. And here, this combination, large sensors, a lot of pixels, plus fast interface, is really key to keep your production speed up. Yeah.
Is there a point that you're actually competing with the other standards?
With what?
With the other standards. For example,
Yes, of course.
if
Yes.
I talk about Mark, what he's presenting today is over fiber, and the length that they are achieving, 40 kilometers, did you say?
Yeah.
Around 40 kilometers?
Yeah, I mean, of course, there's also fiber-based Ethernet cables. I didn't deal with this, which definitely overcomes the 100-meter length. But it's clear, for example, when you need to go to 40, 50 gigabits per second, there are some vendors who try to do this on Ethernet, but this I would always go to CoExpress. This standard is made for this kind of even faster.
Yeah, but you said there are some vendors who are doing this.
Yes.
So it's beyond the standard, or they are doing something on their own on top of the standard?
I think they're doing it on top of the standard by their own. Yeah.
Okay, good. Yeah, that was another thing that was ticking. How, when you're comparing standards, how you're comparing the standards. That's why I came back with that question. And what is the length that that you can achieve with 10 gigi again?
So the lens has nothing to do with 10 gigi.
Yeah,
I'm just saying, when you want to do larger sensors, you need a larger lens, and we will use the TFL mount.
No, I'm not talking about length. I'm saying length.
Length of
length
the
of
I thought you
transmission.
said lens. What was the question?
Because Mark said it's, for example, when you're talking about stadiums, big stadiums, then and 40 kilometers, you have to transmit the
Yes.
signal over a large
Yes.
length. Then you can take advantage of CoExpress over fiber, for
Yes,
example.
I mean, everything which goes beyond, let's say, the maximum copper length, you have to go to fiber. And as Mark said, there's fiber solutions for CoExpress, as there are fiber solutions also for Ethernet.
Okay.
So there are these examples where you need this very long cable length, where you cannot, by the nature and the physics of copper, you cannot achieve this anymore with copper cables. That's true.
Perfect. One small question I have for you. I don't want you to
No,
to hold
go
you
ahead.
here for long.
It's fine for me.
But it's a very basic question, because we are talking about standards here, and all of you as manufacturers are providing that standards on your products.
Yes.
So the basic question is, if all of you are providing the same standard, then how do you compete? Or how do you earn money on top of that?
Yeah. So first of all, I think it was one of the most important moves of the vision industry to standards, because that allows really to compete, and you're not locking people into the component and software from one vendor. And yeah, you could say, why is this good? Because we believe this brings the industry to growth. It allows competition. It allows a broader range of applications, bringing prices down, allowing us all to grow. But of course, every company has its own area of innovation where we, building on the standards, it's kind of how do we assure image quality? What image pipeline do we build on the cameras? What kind of software modules do we provide for our cameras, and so on? So I think the existence of industry standards do not limit innovation. And it's rather the other way. They focus on innovation in other areas we might not have time to build on if we didn't have the standards. So
Perfectly answered. I mean, I completely agree. But since I get this question quite often, working in standards myself, I thought I would ask an expert as well.
yes.
Thank you so much for your talk. If someone else has more questions, we can always come back to you, right?
Thank you very much.